Four spheres A, B, C and D of different metals but of same radius and emissivity are kept at same temperature. The ratio of their densities are 2:3:5:1 and ratio of their specific heats are 3:5:4:4. Which sphere will show the fastest rate of cooling initially? The amount of heat that will actually be liberated by the body shall have the effect on decreasing their temperature. So for this A, B, C and D, A, B, C and D, the densities are in ratio of how much? It was 2 rho, 3 rho, 5 rho and it is rho, and the specific heat capacities are, it is 3s, 5s, it is 4s and it is 4s, let's say, for the time being. Now let's say dq is the amount of energy liberated by all of these systems, then it must have a function of sigma into E into area here, 4 pi r square into T to the power 4 temperature of the body minus surrounding temperature into dt. This is the time here, and corresponding to that they must have the decrement in temperature, so it must be written down as ms into dt. How much is the value of mass here? 4/3 pi r cube. This is the density function I'm writing here. Let's say it is rho 1 and specific heat capacity is S1 into change in temperature is dt. This is the negative sign because it is decreasing. So the rate of the cooling, it must be equal to minus dt by dt. Okay, how much is the value here? It will come out to be sigma E 4 pi r square T to the power 4 T naught to the power 4 divide by 4/3 pi r cube rho 1 into S1. Effectively it is proportional to 1 by rho 1 into S1, where rho 1 and S1 are their density and specific heat capacity respectively. So clearly we see here the product of density and specific heat capacity is going to decide the rate of cooling. So clearly we see this product here is 6, this product being how much? It is 15, it is 20 and this is 4. So smaller is the product of density and specific heat capacity, higher is the rate of cooling. So we are confirmed that body D shall have the highest rate of cooling. That means option 4 is the correct answer for question number 11. Now let's proceed to question number 12. In question number 12, the diameter of a gas bubble formed at the bottom of a pond is d meter. If depth of the pond is 10.2 meter, then find the diameter of the gas bubble when it reaches the water surface. Assume expansion of gas bubble to be an isothermal process and take atmospheric pressure to be equal to 75 centimeter of mercury, specific gravity of mercury to be taken as 13.6. So what I would say, let this being the depth here, at this point the pressure is P1 for the time being. So definitely P1 and the volume being how much? 4/3 pi r cube. It is d divided by 2 whole cube. It must be the pressure at this point. It is P0 into 4/3 pi. Let's say the diameter now is T1 by 2 whole cube. So this one will cancel out and this 2 will also cancel out. We are left with d1 whole cube into P0 must be equal to P1 into d whole cube. Okay, what is the relation between this P1 and P0? This depth was how much? It is 10.2 meter. So P1 will be taken as P0 plus rho g into h. The value of P0 will correspond to 75 centimeter of mercury column. That means 75 in centimeter into 13.6 rho of water into g. This will be the pressure in terms of water column. And what about the extra pressure of this much of the height of the water column? It is rho into g to be taken as g itself, and this is how much? 10.2 meter. That means this much of centimeter of water column. Multiplying this factor 75 into 13.6, we are getting this value to be same as 1020 centimeter of the water column. That means if the pressure here initially was P naught, then at this much of the depth it would be how much? 2 P naught. So we are getting the value of P1 to be equal to 2 P naught. So simply writing down this value here, it is D1 whole cube, P naught must be taken as 2 P naught D whole cube. And how much is the value of D1 this time? It is D to the power 1 by 3. So for question number 12, we are getting option 3 as the correct answer. Now we shall proceed to question number 13. Here in question number 13, which of the following statement is not correct? Work done by conservative force in a closed path is always zero. It's actually from the definition itself. That is the correct statement. Conservation of linear momentum is direct consequence of Newton's third law of motion. That is also from the definition itself, and that is the correct statement. Constant aerial velocity of a planet is direct consequence of gravitational force being central force in nature. That is yet again I would say from the theoretical concept itself. So all these three, option 1, 2 and 3 are actually the correct statement. Pseudo forces shall always have torque about the center of mass of a rotating body. That is actually the wrong statement. But here we need to mark the wrong statement. So for question number 13, we are getting option 4 as the correct answer. Now let's proceed to question number 14. A particle is moving with constant acceleration a as shown in figure. At some instant, velocity vector and acceleration vector are at angle theta with respect to each other as shown here. Find the minimum radius of curvature during the motion, angle theta being obtuse. That yet again I would say a very standard condition here. The situation when the velocity shall only have the perpendicular component to the acceleration, then only the radius of curvature will be minimum. So let this is the acceleration vector. This angle initially was how much? Theta. So this angle being pi minus theta. This is the velocity v. So the velocity component along this direction I would say it is v cos of pi minus theta, and velocity component along this direction it will be v sine of pi minus theta, or simply v sine theta. With the effect of this acceleration, this velocity component will reduce and will become 0, and at the instant when we shall only have this velocity component remained with the particle, then there would be the least radius of curvature. And how much it would be? It would be a normal, that is the value of a here, must be equal to v square divided by r. It is v square sine square theta divided by r, and r would be equal to v square sine square theta divided by a. That's the answer for question number 14. So it is option 2 is the correct answer. Now let's proceed to question number 15. Here in question number 15, a uniform rod AB of mass m and length L rests on a smooth horizontal surface. An impulse P is applied to a distance of L by 4 from one of the end of the rod and perpendicular to its length. Find the distance traveled by the center of rod till rod turns through 90 degree. Two different important concepts that actually being used here. First one is the conservation of linear momentum. Let's say this is the center here and the impulse is being transmitted at this point. This distance being how much? It's been given as L by 4. So after the impulse, the velocity of center of mass, let's say it becomes v naught. So I would say mv naught must be equal to p. This is our first equation. And the angular momentum about this point, how much it was? It was p into L by 4. So after the impulse, it is actually rotating with, let's say, angular velocity omega. Then I would say omega into moment of inertia about this point, it will be ml square divided by 12. So from here I'll be getting this value of omega to be equal to 3p divided by ml. For the next stage of calculation, it's been said that distance traveled by the center of rod till it turns through 90 degrees. So omega, let the time being t naught, must be equal to pi by 2, or t naught will be how much? It will be pi by 2 omega. So the distance traveled by the center, it is s is equal to, it is how much? V naught into t naught. So it will be v naught divided by 2 omega into pi here, have this value of v0 and omega. We shall have this distance s is equal to v0 was how much? It was p divided by m into pi here into 2, and the value of omega that we found, it was 3p. Here it is m and l. So this m will cancel out, this p will cancel out, and we are getting the value of s to be equal to pi l divided by 6. So for question number 15, we are getting option 3 as the correct answer. Now let's proceed to question number 16.